Good evening from Stockholm and Ericsson. Thank you for inviting me. I will start with mission critical communication within Ericsson. We are a unit working across all products. We are identifying use cases that we addressing with this critical communication. See what is needed to be enhanced within Ericsson product portfolio. Could be within security, robustness, resilience, different areas that are key for critical communication. Then we work with 4 different verticals. I will just briefly introduce these 4 verticals. And the first one is public safety, which is the key topic of the presentation I will give today. Here we see that it's happening today. Many countries have ongoing projects how to complement existing LMR, being Tetra P25 systems, with a critical broadband overlay, and later on migrating to have one system for both broadband and voice communication. We have utilities. Coming back to what's happening here is very important, going from a few energy sources to many. Many meaning that there are a number of solar cells, private house adding capacity to the grid. We have wind farms. So the number of sources of energy is increasing for every day, and the complexity of managing the grid is increasing. And for this, 5G can contribute by low latency, wireless connection, connecting the information for a management grid to take the decision how to control this grid. It also plays a role in the workforce. We have seen in many countries, last I saw it from Florida, utility companies have deployed 900 drones for inspections of the grid after storms, becoming more efficient. The workers, the security, safety of the workforce, having more efficient tools to deal with different disaster scenarios. So this is something that we see already happening, quite mature. In Europe, it's a little bit experimenting. In US, we see real implementation happening right now. The rail sector, today we have signaling systems for the rails called GSMR. This will move in a few years from now. It's still on discussion, standardization, early tries to the next generation signaling system for rail, future rail mobile communication system. What we see happening right now is this train system, which have a different signaling system, moving a bit slower today, mainly based on Wi-Fi, moving to LTE. We also see increased demand of communication for passenger, want to be connected while they traveling in train, don't want to be offline, so to say. And then the 4th vertical we work within this is government. Here we have the same portfolio, but it could be a specific use case addressing a need of the society working directly with the government here. So this, I think, is a very good picture, which is actually reality in many countries. We have a young boy here consuming different services from different social media, streaming services. We're having new generations of 3G, 4G, 5G. The bandwidth, the throughput is increasing all the time. But then we have the men and women saving our life and property. They have great systems for voice communication today, delivering critical voice, but they still have very limited data. It's only few with this kind of LMR systems. And to become more effective, they need critical broadband to enable new ways of working as a toolbox for them. Of course, already today, we see that within public safety, taking police as an example, because today they're already using broadband. Taking an example from the Swedish police, a number of years ago, they bought 10,000 iPhones, have the best effort mobile broadband from the operator, allowing them to use databases. Give an example, before introduction of this best effort broadband, if you got caught for speeding. Hope you don't. But anyway, they made a callback request to the control room, asking them to check your driving license, driving plate, and all of this. Today, they can do it directly while they're standing on the road, becoming more efficient. But this is easy win with best effort. It doesn't matter if they don't have the connection. But if you're introducing tools that is meaning of life and death, then you need a critical broadband connection, which always will provide the services for you. So you can really trust that you can use these tools for your work in saving life and property. And this is, as I said, ongoing in many countries. In Sweden right now, MSB, the Civil Crisis Management Bureau, they have a TETRA system. They have started, they got the task from the Swedish government to explore the next generation, starting with the critical broadband overlay. We later on have an example for Finland, have already started this journey, and a lot of other countries in Europe starting, as I said, with this critical broadband overlay. I will not drill down in the different use cases. And in the end, it's important we provide the connectivity, the critical connectivity, and we see already with 4G, we can provide broadband with the defined quality of service, high security, possibility to connect a lot of sensors. Later on, moving to 5G, it will be low latency, ultra low latency. We will have a different way to have even more critical sensors. But and you can see a number of different use cases that we see as a possible scenarios. But the important here is that this connectivity will bring services that should support men and women working. So this is a tool and support, not the primary that they should have a lot of advanced applications. Every application, every solution that we bring should make their work more efficient. They should have better security, better safety, treat people with more efficiency, and so on. That is the key for all scenarios, I would say. And I will show a simulation or animation here of a wildfire seminar. And in this case, we can say that we have operators providing very good coverage. Often when they move into this critical broadband, they make an analysis if they need to enhance this coverage to extend in some certain areas of the country. But in all cases, there will always be part of any countries where you will not have coverage. So the usage of system on wheels, as we call it, you have a deployable, which actually you can bring the coverage to a certain area. And in this animation that you will see that it simulates a fire. We will have the fire trucks that bring the coverage and use this coverage on for fighting. So I will start the simulation here. So here's a fire, and then we have the fire trucks coming, and they will then deploy coverage on the scene because this is outside the operator coverage. And you can have different solutions, cell on wheels or system on wheels. You establish coverage in the area that you would like to operate in. And then they have the drone supporting this situation awareness, collecting data, and support the men and women fighting the fire with accurate data to the control how to address this. And then later on, when they have put on the fire, you can use the sensors, the heat-seeking cameras to actually monitor the area. Have you really done a good work? Is there any fire coming back? And even though you can keep this coverage in this area, and you could use different form of AI to automatic control and search the area if the fire is coming back to become more effective. Not having people that need to walk through the woods and looking for fire coming back. You can use the drones, and you could have automatic search patterns and so on with the coverage. And when the mission is completed, you could take away the coverage. And this is a very typical scenario. And this is not just the future. This is actually something happening. already, and we can see that in many of our customers that this kind of deployments are happening. So an example I want to share with you here is a truck we have done together with a US operator, Verizon. It's Ericsson hardware and software inside. It's actually this system on wheels that was displayed in the animation that you can bring to any site and establish coverage and then secure that you have critical communication during any operation. So I will play a little bit YouTube. It's a 1.5 minute and get an introduction of this.
Thor is our tactical and humanitarian operations response platform. First responders react to situations where sometimes networks may be wiped out. What Thor does is it comes in, and regardless of what the devastation could be in a particular area, a vehicle like this can set up coverage and provide the necessary needs for first responders until the infrastructure gets brought back up. It has a fully enclosed network in its command center. We put the critical components of a network that would historically be in a data center in the truck, including 5G ultra-wideband. We incorporated all the latest tech into the vehicle. We put what we call a MAC, mobile edge compute, on board. Now we could put applications on the vehicle. We thought it was imperative to be able to deploy Thor in a very agile and quick method. So we designed it to be controlled by a tablet. The tablet can turn up the network, raise the masts, turn up the generators. This allows us one central location to control everything on board and do it quickly. There's a door that opens up on the top. A drone gets sent up in the air, takes a video of the surrounding area. That video can get then sent back to first responders that are on the ground, and now they can see everything around them. We'd love to see Thor really evolve. We're constantly looking at new tech and new ways of incorporating new capabilities. Our job's not done.
This Thor was one example happening in US. We see similar solutions are built in Europe. Then moving to Sweden, what's happening in Sweden? I mentioned the procurement that MSB is doing for this next generation Rakel, as the network is called, starting with this broadband overlay. We also have with Teracom, is a Swedish governmental operator doing TV broadcast, but they also have spectrum in 450 megahertz and 2.3 gigahertz. We have been trialing with Teracom in 2 different trials, exploring how to build air-to-ground network, meaning that how to secure critical communication up to 5,000 meters. And looking at existing TETRA networks, this is often not maybe to this altitude of 5,000, but anyway, they have the possibility from slow flying aircrafts and helicopters to do group communication already today. That's an important way of the way of working. So of course, when they move into critical broadband, they also want to make sure that they have this broadband capabilities up in the air. So this is actually built today, is rolling out, will cover 96% of Sweden's geographical area, and will allow then aircrafts, slow flying aircrafts, and helicopters and drones to be connected. And the next step of this, which we see happening all over the world, and this is not just for public safety, it will happen, I mean, thinking of the delivering of package and all of this, but for our part, the digital airspace, it's many different areas, but short we can say it, how to fly drones beyond line of sight, control them from the 5G networks or LTE network to start with actually, and fulfill the regulations, because there are a lot of regulations when it comes to flying drones beyond line of sight. And this is controlled by centralized bodies in Europe, how these regulations should look like, and different countries have a little bit different speed and approach, but there is a roadmap. And the important part is that we have technology, we have connectivity that could support this flying of drones. I met the Swedish police just a few weeks ago. They have today 300 drones, and next year they have 600 drones, I think, to make situation awareness and other missions with. And the cost to fly drones compared to a helicopter, of course, it's much less. And in the future, when you can have advanced and maybe many drones searching for people, missing people and other things with heat cameras and searching big areas, very effective. So it's endless possibilities with drones, as we all know, and they become more and more important. But of course, the safety, drone can fall down, people on the ground and all of this. So there are a lot of regulations. And that's part of the digital airspace program that we're working with. My last slide, few references. As mentioned, I will not go down to exact technology, but what is Spring. We have FirstNet. It's a public safety network with AT&T, AT&T being an operator in US, providing critical communication for the first responders. We also have in US Southern Wireless, which is an energy company that doing this journey with the grid and also providing communication for the workers, I mean push-to-talk communication. They also sell this kind of services to other companies that need this type of communication, group communication services. Then in Finland, as I mentioned, they are a little bit ahead of Sweden. Already almost 2 years ago, they started the journey by procuring a dedicated or government-controlled network, and that is the data centers with the software, you can say, that they procured, and then they using an operator access network, mean the infrastructure that you can see out in the terrain, the masts and antennas and all of that. So they cooperate with the operator on that part, and then they have one part in the government because they want to make sure that they have the control. And I can see that in Sweden, a little bit following the same pattern, that it will be the data center part will be controlled by MSP, being part of the government. So this was my last slide. Thank you.
Thank you, Niklas. Very interesting.